Hello and welcome to the next video on setting up your Viola chart inside of Tableau. We're getting very close and it's exciting to be here. We've finished everything inside of Excel. We've finished everything in terms of data importing into Tableau, and we've created our data densification. And I actually wanted to comment on that process a little bit. I know it can seem a little bit tedious. I know there was a lot we had to go through, and you're doing great hanging in here. The thing is, I was trying with this challenge to replicate a real-world situation. A lot of times in classroom environments like this, you will be given a data set. It's nice and clean, everything's done for you, and you can go in and build your views in 5 minutes. The thing is, when working with real data, it's just frankly not clean. You have to learn the process of cleaning it, of setting it up, and making it so that you can use that data to build your views. That being said, all that's done now, that's behind us, so let's get in and actually build our views. So right here, we've got our data densification going on. We have all these marks across the view. If we put in a quick index function, we can then see we have values 1 through 49. Now our first calculation is actually going to be a variant on that index. We're going to call it t for reasons that you'll see in a little bit. So this is going to be open parentheses, index, minus 25 divided by 4. What this does is it creates a scaling factor for t, basically. So if you remember index before, we had the straight line. This right here is also a straight line, but it also allows us to include these negative values. It also wraps all 49 marks between -6 and 6, helping us draw a nice smooth chart as we work through. Now the reason that we named it t is because t is actually a value in the formula for the curve that we want to calculate. It's going to be our next calculated field. It's called sigmoid. The formula for it is some straight math. It's 1 over 1 plus e. Now e is a mathematical number that Tableau doesn't give you access to, but we do have the exp function. exp returns e raised to the power of the given number. Example, exp 5 is equal to e to the 5th. So exp 1 is e to the 1st. So we have 1 over 1 plus e raised to the negative, very important, t. What this does is it creates a situation where that scaled index value is used as an input to the calculation, so this curve is drawn across our padded values. Drag that up, and you'll see we have this nice curve that now exists across our data set. Now that's just the sigmoid though. We need to create more calculations so that this sigmoid can be scaled against the actual values we have. So we're going to need to create another curve calculation. But first, we need to bring in these two values. So if you look at our start percent or our end percent, they'll show the same thing. You realize we actually are in trouble in the sense that we only have two values. And that makes sense. We only have the value of 1 and 49 in our data set. That's because this is a non-window calculation. So what we're going to do is create two calculations. And by window, I meant table calculations, sorry. Similar syntax and similar descriptions that can get mixed up sometimes. But we'll call this a table start percent. And we're going to wrap it in a 0 null because we start with null, right? And so we want to make sure that starts at 0. Running average of the sum of our start percent. Close parenthesis to wrap off that 0 null. 0 null says if there's a null value, make it 0 rather than just returning blanks. Running average says take the average across the table of the sum of starting percent as you move across it. So rather than window average, which looks across the entire table as you go, running average calculates as you go along. In this case, you're going to have your first value of start percent averaged, which is always going to be exactly the same, and then your last value, which will be the exact same, so you're going to have this constant start percent across your entire table. Right-click on that and duplicate. Rather than table start percent, we want our table end percent. Come up, get rid of that copy as well. Then 0 null running average sum of our end percent. So now we have our starting point and our ending point, and we can create a calculation for our curve. We'll just call it curve. We'll take our starting point, our table start percent, and then we'll add in the difference between our two endpoints, our two sides of the view. So we have our table end% minus our table start%. Then you multiply that by the sigmoid. So you can imagine table start%, just imagine it down here as 1. Table end%, imagine it up here as 10. You have to get from 1 all the way up to 10. If you move across your table and subtract where you're starting from where you're ending up, you'll eventually get there. Multiplying it by the sigmoid makes it so that it actually implements that curve as you go across your table. With that curve calculation, we're actually all set now to build our view. We're going to take the curve and t along with some dimensions here, bring padded over, and we're building out our view, but we're going to save that for the next video. You guys have done great hanging in here so far. Give you a little break, and then we'll come back in the next video and build out that core chart. See you then. Thanks.